right, this is the 2016 official practice test. In this video, I'm going to work multiple choice 16 through 23, and I'm going to focus on the 2020 test. So if I hit any that I don't think will be on the 2020 test, I'll tell you why. So number 16 gives you a slope field. Okay, and so what you want to do, it says that dy dx is equal to x squared plus y. And dy dx, of course, just gives you the slope at a particular point. So what you want to do is try some values, some easy values, and see if any are eliminated. So the first one that I tried was x is 0 and y is 0. That gives you a slope of 0 because it's 0 plus 0. And going through and looking at the 0, 0 point on all of these, it has a horizontal line. So that doesn't eliminate anything. So let's try another easy number. I tried x is equal to 1 and y is equal to 0. So if x is equal to 1 and y is equal to 0, that would give you a slope of 1. Okay, so looking through these, x is 1 and y is 0. A looks like a slope of 1. B doesn't. B has a negative slope there, so B can be eliminated. C and D are still in the mix, so that one eliminates B. And you may pick different numbers, okay? So then I decided to try one that was on the negative side of the graph. So I tried x is negative 1 and y is equal to 1. So if you plug negative 1 in, you'll get positive 1 plus 1, so you get a slope of 2. So let's look where x is negative 1 and y is positive 1. Which ones do we have a slope of 2? Well, right here we have a slope of 0, so A is eliminated. B was already eliminated before. C has a slope of 0 also at that point, so it's eliminated. Then D does have a slope of 2 there, so the only one that is left is D. So on these, it's a trial and error process. For me, I just try a few simpler ones. You try 0, 0 first, and then maybe going to the positive side of the graph, and then maybe moving to the negative side of the graph if you can't. But hopefully you'll get the right answer within 3 or 4 picks. All right, so I'll let you pause the video if you need to. That's number 16. Okay, number 17 says we have the function y is equal to e to the 3x minus 5x plus 7 is a solution to which of the following differential equations? Okay, so basically what we have to do is go through and figure out y prime and y double prime and see which one works. Okay, so y prime is going to be equal to, okay, e to the 3x times 3, so 3e to the 3x minus 5. And then y double prime, the second derivative, would be 3e to the 3x times 3, so that's 9e to the 3x. And then the derivative of 5 is 0. So let's just try A. We have to just basically plug what we have, y double prime, y prime, into the answer. So for part A, it says the answer is y double prime minus 3y prime minus 15 is equal to 0. So let's plug in our answers for y double prime and y prime and see if it ends up being 0. So we have y double prime is 9e to the 3x. Y prime, so it's going to be 3, and y prime is times 3e to the 3x minus 5. And then minus 15 is equal to 0. So let's see if that's true. So we'd have 9e to the 3x. Distribute the negative 3, so minus 9e to the 3x plus 15 minus 15 is equal to 0. And that is true. The 9s and the 15s cancel out. So we got it on the first try, but let's say you didn't, you'd have to go through B, C, and D and keep trying those options until you got it. All right, so that is number 17. That one worked out for us pretty quick. All right, number 18, we have f of x is equal to the inverse sine of x. We want to know what is f prime of the square root of 3 over 2. Now they're trying to trick you here to see if you'll just look at the unit circle and see if you plug what's the inverse sine of root 3 over 2, and of course that's pi over 3, but it's not asking for that. It's asking what is f prime, so we have to take the derivative. And since the 2020 test, you're going to have open notes for that, you could flip in your notebook real quick and find the sheet that has the derivative of inverse sine, and it's this, 1 over the square root of 1 minus x squared. So f prime of the square root of 3 over 2 will be 1 over the square root of 1 minus the square root of 3 over 2 all squared. So that is 1 over the square root of 1 minus 3/4, which would be 1 over the square root of a fourth. What's the square root of a fourth? It's a half. So that's 1 over a half, which is 2, which is answer D. So they are really trying to trick you on that one and see and just get you to put the unit circle answer in. But if it were, it's not asking for f of root 3 over 2. It's asking for f prime of root 3 over 2. So you have to take the derivative. All right, so that's number 18. Let's get number 19. Now, I really believe there's a great chance you could see one like this on the 2020 test. They're going to make you take a limit, and they're probably going to see if you know L'Hopital's rule. So we've got x to the 20th minus 3x minus e to the 20th minus 3e over x minus e. And of course that's going to give you 0 over 0. Let's first of all let's clean the numerator up here. So we've got x to the 20th minus 3x minus e to the 20th plus 3e over x minus e. And when you use L'Hopital's rule, you need to write like an LH, okay, to show them that you're doing that. So that's the limit as x approaches e, and we're going to take the derivative of the top, which is 20x to the 19th minus 3, and then these are just numbers. E is just a number, so those derivatives are 0. And then on the bottom, what's the derivative of x? It's 1. What's the derivative of e? It's 0, so that's just that. Now we can plug in e. So that will be 20e to the 19th minus 3, which is answer B. All right, so there you go. It's so much easier to use L'Hopital's rule to evaluate a limit than to doing all the factoring and canceling and all sorts of other stuff that you would have to do. I don't even know how you would work this one without using L'Hopital's rule. Okay, number 20 says let y equals f of x be a twice differentiable function so that f of 1 is equal to 2, and our first derivative, dy dx, is equal to y cubed plus 3. And we want to find out what is the second derivative at x equals 1. So first of all, we need to take the second derivative here. So The second derivative is going to be, let's bring that 3 out front, so it's going to be 3y squared, but don't forget the dy dx, and then the derivative of 3 is 0. So we know that dy dx is y cubed plus 3, so we can just plug that in. We've got 3y squared times y cubed plus 3. Okay, so there's no x's there, but we know that our y value is 2. So that's 3 times 2 squared, 2 cubed, plus 3. That's 3 times 4 times 11. You'll have a calculator available. So, but I would think, okay, that's 33 times 4, so 320 plus, so it'd be 132. But you just use your calculator on that one. Okay, pretty cool, the problem, and you just got to remember, hey, I know dy dx, I need to substitute it back in right there. Okay, let's look at 21. Now, 21 refers to a table that I would rather not rewrite. So if you'll just follow along. So it's the table on this page. You got values for f of x, f prime of x, g prime of x. And it says h of x is equal to f of g of x. What is h prime of 1? Well, h prime of x, so this is a nested function, a function within a function, so we'd use the chain rule. So it's f prime of g of x. So think of g of x as the blob. So it's f prime of the blob times the derivative of the blob, which is g prime of x. So h prime of 1 is equal to f prime of g of 1 times g prime of 1. And now we're just going to look at the table. So that's, what is g of 1 in the table? Okay, well, g of 1 is 3. So it's f prime of 3 times, what is g prime of 1? G prime of 1 is negative 2. So what is f prime of 3? Let's look at the table. F prime of 3 is 7. So that's 7 times negative 2, which is negative 14. And that is answer B. All right, so it's just, they're testing, do you know the chain rule, and does it freak you out that it's not just x's and y's, but it's functions? All right. I could see one like that being on there. Number 22. We have dy dx is equal to x plus 1 over y. Our initial condition is f of 0 is equal to negative 2. And then it gives us some expressions for f of x. So basically, this is a differential equation. We've got to get our equation for y and see which of those letters match it. Let's separate the variables. I would be shocked if you don't have one like this on the test where you have to separate the variables. So I'm going to cross multiply. We're going to integrate both sides. So it's going to be 1/2 y squared is equal to 1/2 x squared plus x. Antiderivative of 1 is x. Don't make that 0. Plus c. Now let's put in the initial condition of 0 and negative 2. So that's 1/2 times negative 2 squared. 0, 0, so it just is equal to c. So we would have 2 is equal to c. So I've got 1/2 y squared is equal to 1/2 x squared plus x plus 2. All right, we just got to solve for y here. So let's multiply both sides by 2. That'll eliminate this 1/2 out front. So that'd be x squared plus 2x plus 4. And then let's take the square root. So that would be plus or minus x squared plus 2x plus 4. So looking at your answers, it could be C or it could be D, but since our first value for y is negative, we're going to take the negative side of that. Okay, so that is going to be option C. So that was a little twist there at the end to get that. Probably on yours you wouldn't have to do that on the 2020 test. You would just write plus or minus for that one. All right, our last one for this video is number 23. So number 23 asks you to get the volume of the solid generated around the x-axis. And it grieves me because you know how to do this. You could find that one. You would know that this is the washer method, and you know how to get the outer radius and the inner radius. In fact, the answer for this one is C. So, you know, feel free if you want to just to look through that and see if you agree, but number 23 is not on the 2020 test. So you don't need to be studying how to get volumes revolved around axes. That's the end of this video. We'll go through number 30 on the next one, and I'll see you next video.